Now we need to turn our attention to understanding about learning about logarithmic functions and logarithmic form. Let's say we have log base 5 of 25 equals 2. That is a logarithmic equation, and that 5 is written as a subscript. In exponential form, the same equation would be 5 squared is equal to 25. In other words, you have 5 raised to the second power on the other side equals the argument of a logarithm. Now there's no name for this property other than just converting between logarithmic and exponential form, but I kind of like to call this the visual property because you kind of see the pattern developing. Let's say we had log base 3 of 1/27 is equal to -3. In this case, 3 the base, getting raised to the -3 power on the other side, is equal to 1/27. In logarithmic form, or in exponential form, that's 3 to the -3rd equals 1/27. Let's say, third example, we have log base 64 of 16 is equal to 2/3. Yet again, using this visual property, oops, I should not have put that extra equal sign in there. That should just be a parentheses there, if at all. We have 64 to the 2/3 power is equal to 16. Now, we haven't done any fractional exponents in this course yet, but you should remember from your previous course that the 3 down in the denominator there stands for a cube root, and that 2 stands for a second power. So if we cube root the 64, we get 4, and then square it, we get 16. So this is consistent. And likewise, if we have log base w of r is equal to z, we can write w to the zth power is equal to r. W to the zth is equal to r. Now what's a little bit weird is when you're going in the other direction. If we had 3 to the 4th is equal to 81, my brain doesn't like to translate that very easily to the logarithmic form. What I like to do is just go, okay, log base something of something equals something, and then I pretty much go with this pattern and say, okay, my 3 is down below here. It's being raised to the 4th power on the right to equal the 81 inside, and that way I can go from the right to the left. Now I want to call attention to a couple things in this chart. Notice the bases are always positive numbers, 5, 3, 64. Whereas if there's a negative involved, it's on the right, or the fraction is negative. We're allowed to have negative exponents. We're not allowed to have negative bases, nor is the argument of a logarithm allowed to be negative.